Boa tarde, estudantes. It's Portuguese. It's Portuguese. Buenos tardes, estudiantes. Yeah, boom. Very similar. Klein. What's up? Cool. Thought you were sleeping. My bad. Okay. All right. So check it out. This is gonna be weird. We're gonna write some stuff, and I'm gonna write some stuff before we ever commit to it. What's a triangle? Okay, so I heard a bunch of stuff. 3 sides, 3 angles. Those 3 angles add up to 180. Cool. Okay, if I said, draw me 3 different types of triangles, could you? Okay, I'm going to sketch a bunch of triangles. You don't need to draw them yet, but you're going to help me figure out what would we call this. Okay, we are back in middle school because I imagine you've seen all these words. This triangle right here could have 2 different ways to talk about it. Can somebody give me one of them? Obtuse. What on earth does obtuse mean? Greater than 90. This angle right here is bigger than 90, right? Okay, you do not have to write these yet, just so you know. 100% this is obtuse. Anything else that you could use to classify it? What on earth does scalene mean? Scalene? All 3 sides are different lengths. This triangle, don't draw this yet, we're just talking. Obtuse and scalene. Cool. Does anybody not ever remember seeing either of these words? Okay. So I'm going to draw another triangle, and it's fantastic. And I'll even mark this. It's a right triangle. It's a right triangle, and it's isosceles. How do you spell that? That's right, Isosceles. Okay, do you guys recognize right? Okay, what does this word mean? Ooh, love that catch that you made. Okay, it's not just it's isosceles. Isosceles, not just I almost hit you in the face. I'm so sorry. Okay, all right, well, is this an ugly triangle? Is this one ugly in your head?
No.
Well, can we all agree that this one's super cute? Okay, so this one could be a cute, right? What does a cute mean?
Less than 90.
All the angles are less than 90. Could we ever have a triangle with more than one angle bigger than 90? What? Not in 2D space. Because what do the insides add up to? If we have 2 that are bigger than 90, we break it. Okay, this triangle, it's acute. All the angles are small. What if I do this? What if I do this? This is now all the sides, all the laterals are equal. Equilateral. Is this isosceles?
Yes.
All right. Well, the good news is we're going to dig into these, and we've hit every type of triangle here. For today, this section, we might have another section named the exact same, just so you're aware. Because I'm going to name it differently so we don't just have to write the same stuff. We are looking today at 4.2, and we're going to look at some special triangles. Now, whether we do the proof today or start proving stuff today or not, we'll see. Some special triangles are what we are after. Now, one might be able to argue that all triangles are special in their own way, and that might be true, but there's 2 different triangles that we had on the board here that are the ones that have some really special properties that are going to help us while we go through triangle congruent stuff. So the first of these, we're going to define isosceles triangles. Okay, I'm going to pause here. I'm going to keep writing in just a moment. That is my shorthand for isosceles. If I were taking notes or if I'm doing a proof, this is my shorthand, isos, just like this. Isosceles. Okay. Isosceles triangle. Anybody have it? It is. Anybody have an objection to me using triangle, that shape, a triangle, for the word triangle? Okay. Nobody's going to misinterpret and say isosceles deltas? Deal. Okay. What's an isosceles triangle?
Triangle with no equal sides.
So that one's scalene.
Oh, 2 equal sides.
Love it. Okay. When I first heard this, Mr. Nelson said 2 equal sides. He said, no, at least 2 equal sides. And then just now, Honor said 2 or more sides, which is the same statement. For an isosceles triangle to exist, all we need is at least 2 congruent sides. At least.
So it can have more.
It could have 3, but it has to have 2. which means every equilateral is an isosceles. So at least two congruent sides. Now, when we name them, it's always super weird when we think about this, but check it out. Here's a glue stick, and it is meant to stand up straight, right? So right now, without putting it on the ground, I'm going to hold it wonky. If this sits the way that it should, what shape is its base? So the whole thing is a cylinder. What's the shape of just the bottom where it sits? We all agree it's a circle. Now, it's because, even without me holding it, you guys all assume it sits like this. Okay, if I hold it like this, does it still seem reasonable to you guys to say the base is still a circle? Like, you might be able to argue one of two. You might think it's just a straight line, but if we work with the assumption that it should sit the way it's supposed to, even though it's on its side, can we all agree that the base is still a circle? It's just tipped over sideways. Okay, now as we look at this then, we are going to see something with these triangles, and I try to stay consistent, at least as consistent as possible. Not all textbooks do this or do it consistently throughout everything, but we're going to look at an isosceles triangle, and we're going to get a theorem right off the bat. The cool thing is that if we get a theorem, what does it open up the door for us to do? A theorem. Oh. All right. So here we go. Theorem 4.1. We are not going to prove this one right now. We're going to ramp up. We'll do our proofs tomorrow. Okay. Theorem 4.1 is the isosceles, and I would again shorthand isos if I were you, but we have the isosceles triangle theorem. And I'm just going to, yeah, it feels redundant to write theorem again, but it's fine. Okay. First big question. You guys get like 30 seconds to chat with one another. I'm going to use the phrase if and only if in this theorem. And I need you guys to chat with one another and tell me in 30 seconds time, what does that mean? If and only if. Chat it out. Up here, just to remind us, in pink, it's just for thought. If I write if and only if, P if and only if Q, and I don't want to write 3 words, what's my option? I can either do this, or I can do this. Okay, the arrows make this much more clear. P if and only if Q gives me 2 things. What does it give me? 2 conditional statements. If P, then Q, but additionally, if Q, then P. We get a statement and its converse. Both of them are free for us. It goes both directions. So when we write this theorem, and we're about to do this, we're going to write it with words, and you guys are going to help me draw the pictures. And we're going to actually do the picture first, and you're going to help me with the words. So I'm going to sketch an isosceles triangle. So here's our lovely triangle. And let's call this, and it looks pretty good to me, let's call this triangle Jeff. J-E-F. Ray is also a good choice. Try is a pretty common thing for me. Cool. All right. Do you think this triangle is isosceles?
Yes.
Should you just believe it because I said that it kind of looks like it? What would I have to put on here? So we're going to put some dashes and stuff here in just a second, but let's just say that maybe it's an isosceles. We're going to write our theorem. We're going to make the claim, and here's our theorem at heart right here. Triangle JEF is isosceles if and only if, and we get 2 things. Now, I liked what you guys told me to start. I'm going to go ahead and add those dashes now. Okay, we have at least 2 sides the same. Now, when we name these, and we'll talk about it, there's a way that I prefer to name it. This is isosceles if and only if. Do you guys think there are any angles on this that I can say something else about? Why?
Because they are the ones that go long.
Okay, so we're going to refine that, but I agree with you. We have a statement that says this triangle is isosceles, bless you, if and only if these angles here happen to be congruent. Now, if we need 2 angles congruent, but every triangle has 3 angles, it could be a weird thing to try to keep straight, right? So we need to really focus on how would you explain what these angles are? Like, obviously, we can just call it angle J, but you can't just say bottom left, because if I turn the triangle, it's not bottom left anymore. How do we describe where angle J and F are? So they're on the base. If that side's down, makes sense. But if that side's not down, you're going to be tempted to call the other side the base. Has to be the shortest? Or longest? Can we agree that this angle F, is it adjacent to side JE or opposite from side JE? This angle right here is on the opposite side from this. Okay, so that's what I'm going to use. I'm going to use the opposite or across the triangle, might be the language, but we're going to go ahead and also mark these right here. Now, when we talk about these, you can write these triangles in whatever order. I try as much as I can to be consistent. I put JE and EF, the pieces that are congruent, on the ends. So we have this vertex. Here's JE, the first two, and EF are the second two, so that they match up like this. These things, we're just going to sneak a definition in. Somebody I gave a snarky answer to, but you were actually right. I don't know whoever said it. This side, JF, is the base. Now, it's obvious, and I think everybody would agree just looking at this picture that this is the base of the triangle, 100%. My concern is don't sketch this one. We'll go through this color. What if I drew this triangle like this? Which one's the base here, do you think?
The A, B.
So this is that weird thing, just like we saw with the glue stick. It's natural to want AB to be the base, because when you think about the base of something, it's probably what it rests on. Do we all agree? But if we're going to refer to the base angles as those that are opposite, so it'd be A and C in this one, right? This side is still our base. Even though the other side is down, we use the correct orientation based on just what we agree is correct. I'm going to repeat that. The base is not necessarily just the bottom. Okay, the base of an isosceles is between the congruent sides. So we have the base written here. Are these angles right here found on the base? So if this side is the base, JF, what do you think I might call angle J and angle F? The what angles? They are my base angles, for sure. Base angles. Okay, we will use this consistent language. Henning, am I losing you? Okay. Okay. Awesome. Could we prove that this is true for every possible isosceles? How? So you can't, so maybe, I mean, yes, we can't use the isosceles theorem to prove it. I'm sorry? This is our whole theorem.
There's no more?
Nope. If it's isosceles, then the base angles are congruent. And if you give me a triangle and the base angles are congruent, then I also know it's isosceles. Always. This is just this is the written version of it. So we'll use it. And if it is still confusion, you'll let me know. Okay. So immediately I'm gonna keep this on the board here. We're gonna try to do a problem here. And we're gonna use this theorem. So in this example, all I want you to do is help me find X. Now, just so you guys are aware, I am just being lazy. It really should say find the value of X to avoid people saying, oh, there it is. But cool. We're just under the impression that I want a number, not a point. Okay. So here we go. Let's get wild with it. I'm gonna make up an example, just so you guys are aware. Is it possible that my example is like blah and doesn't really make sense in the end? For sure it is. And let's deal with it. On A, we're going to do a harder one together, and then you guys will do another one on your own. So here's this triangle. Now there's no base because it's sitting on its point. Cool. And here's what I know. We'll call this A, B, C. Now, I'm going to introduce something in your book that hasn't shown up yet, but it might be worth talking about here. Okay. If I wanted to know the three sides of this triangle, can we agree that they're AB, BC, and CA? Okay, there is a convention in geometry. Do you guys always use capital letters when I use capital letters? You should with points and stuff, right? Like with points and lines and stuff, we have to use the specific stuff. This side right here that we would call AB is opposite from which angle? This is side C. This side is opposite from which angle? Lowercase a. This side is opposite from B, so this would be side B of this.
How do you know which side is the base then?
So we haven't gotten there yet. We're going to have to get some stuff. Okay, so here we go. I'm going to add a couple more things. we're going to use the segments just as we're writing it today, but we'll start loading this in a little bit. Okay, here's what I know. This side C, or segment AB, if you'd rather, has a length of pi. This side A over here, or segment BC, also has a length of pi. Okay, down here in angle A, I'm going to go ahead and say that this is x squared plus 2 degrees. And then all the way over here in C, I'm going to draw an arrow to it so I don't have to try to write sideways. Let's say that this one is, got to think it out, negative 3x degrees. Now, am I always going to take time, and should you take time to draw perfectly to scale? No. There's times where I'll specifically just try to annoy the crap out of you guys and throw in a right triangle, but if I don't put the right angle mark, don't assume. Do I have any reason to believe, first of all, that this triangle is isosceles? Why? These two side lengths are pi, right? Are they the same then? And if we have a triangle whose two sides are the same, then it's isosceles. Now, as far as naming this, if I were to name this, and it's natural because we all probably pick the same thing, I would go AB, because I hit that side first, and then BC. So triangle ABC is a natural choice, even if we didn't talk about that. How on earth can we find the value of x here? Can we all agree, and we don't have to write it all, but it's good just to see the logic, that triangle ABC is isosceles? Okay, and we're not proving anything, but we're getting a little practice because we might be rusty with it. It is isosceles. Because it's isosceles, what does that tell me about these angles that we've written? They're equal. No, kind of. They're congruent. Their measures are equal, but we already have their measures written. Okay, these are my base angles. What side of this triangle is the base? Or segment? AC. This is the base. It's between my base angles. So I know that angle A is congruent to angle C, which, because congruent just means their measures are equal, it should allow me to say this: x squared plus 2 equals negative 3x. Does everybody agree and follow with what we've done? Rephrasing that, does anybody not understand what I've done and how we've gotten here? Okay, so now we're continuing on. This is harder than what you're going to see on the homework, just so you're aware. We're trying to introduce that factoring stuff as we got a little practice. What should we set it equal to? What should I do? 180? So 180 is okay. So they are set equal. But now if I want to solve this, how on earth do I solve it? So that's what I've done. They are equal. So find the value of x. Now, can we group it right now or do any shortcuts or anything yet? No. So you're thinking way too hard. Normally, if you look back, we only did one solving, and I might have already erased it. When we solve quadratic stuff, we set it equal to what? 0. Can I make it say 0 on one side? By doing what? Adding 3x. Now, I'm going to do something, and I want you guys to tell me why it annoys you. And don't write exactly what I have. We'll have the same three things. If I write this, does this annoy any of you? It bugs the heck out of me. What bugs you about it? The order's wrong, right? We always go x squared and then x to the first power and then the number. I'm going to rearrange these, and I would always encourage that you do. So x squared plus 3x plus 2 is still equal to what? 0. Okay. We get to solve this, and there is a very clear wrong answer, and I think we've already been through this, but I only want the right answer. What the F word are we going to do? Factor. That's what I was looking for. Perfect. Okay. Let's run through. Is there a greatest common factor between these three? Tristan, I'm going to put you on the spot. If it's not if there is no greatest common factor, what's the next thing we look for? I'm going to rephrase it. If I want to use the shortcut, what do I need? My ears are really itchy. My eyes are burning, so I'm going to take a really long blink real quick. Oh, still itchy, sorry. So you're right, but not quite the question I asked. Is the leading coefficient 1? So that's to everybody, just for the record. Do we all agree the leading coefficient is 1? What's a leading coefficient? The number in front of the biggest power. This is a 1x squared. Okay, so if you need to draw it, you can. Can you guys tell me factors of 2 that add up to 3? 1 and 2. Now, it feels odd to do it, but I'm going to start doing this. It's plus 1 and plus 2. So how do I factor it then?
You just do x squared.
We're just going to use a shortcut. X
plus 1.
plus 1 and x plus 2. We just use those magic numbers. Now, they're both equal to 0. And we saw one problem like this yesterday. We're seeing another one right now. Is there an x value? I have 2 factors on the board, x plus 1 and x plus 2. Is there an x value that makes my first factor, x plus 1, equal to 0?
Negative
0 won't do it.
Negative 1.
Because if I pick 0, it does 0 plus 1 is 1. Would negative 1 do it?
Yes.
Now, if somebody's thinking like, well, I don't quite understand, the work that everybody's doing in their head is just solving this. And everybody in here, I'm certain, can do this in your head. But if you're not quite sure what to write, it can be weird. Negative 1. What value of x makes this one 0? Okay. Right now, we just found x is negative 1 and negative 2, right, Klein? Okay. Does that feel wrong to anybody? Interesting. It felt really wrong to third hour. I'm okay with it if it doesn't. Negative values for a variable are fine. If we wound up with a negative in our angle, it'd be wonky, right? But let's check. Maybe one of these work, maybe both of them work, but we're going to see. I know that this angle, and we're just going to check our work to see if it makes sense, because sometimes we get answers that are wonky. Okay, if I plug in negative 1 for this, it becomes negative 1 squared plus 2. This is angle A. And help me clean this up, and I'm actually going to write this out. Measure of angle A is negative 1 squared plus 2. What's negative 1 squared? 1 plus 2 is 3. Now, does it look like it? Does that, show me with your hands a 3-degree angle. It's like this, right? Like nothing. It's just almost nothing. It's tiny. My picture could be bad. Is 3 degrees reasonable for an angle?
No.
You say no, why?
Yeah, I guess it is.
Like, if we compared it with like negative 12, then it makes way more sense. As long as it's a positive number, we're okay. Okay, positive number less than 180. All right, if that's 3, let's try this one. Negative 3 times negative 1.
Negative 2. Or negative 1 again.
Measure of angle C would be negative 3 times negative 1.
What's the other x squared?
We'll check it. We get 3 degrees. Does that make sense? Should we get the same angle for both?
Yeah.
For A and C, should we have gotten the same? We better. They're equal, right? They're the same angle. We're going to try the other one now. If you're going to pop in the next 4 minutes, yes, because we only have 4 minutes left. 3 minutes. Okay, so 1 worked. I'm cool with that. Negative 1, sorry. Does negative 2 work? If I did this with negative 2, what's negative 2 squared? Plus 2? That gives me 6 degrees. That's a reasonable angle. What's negative 3 times negative 2? And did they match again? Hey, check it out. Our value of x is either, and we'll just write our final answer. For our situation, in this context, x is either negative 1 or x is negative 2. One of those. Now, the cool part about this is I can ask this problem and add a little bit of algebra to it. It makes it a little bit more complex, but there's other stuff that I ask. If I wanted you to find the measure of angle B without anything written here, do we have enough to do it?
Yes.
If this is 3 and 3, then this must be 174. If this is 6 and 6 to get to 12, then this must be 168. And we can see that we can still use all that same stuff. Now, this problem is like significantly harder than the ones that you guys will be doing as an assignment tomorrow. Go to the games tonight if I don't give you homework. Cool. All right. I'm going to give you guys one more to do before we peace out, though. All right. Much more in line with the types of problems that show up on your assignment when you get it. Last one. Here we go. I'm going to draw this. This is kind of your homework, I suppose. So check it out. We get this lovely triangle. And all I know about this is that there's an arc across there and there. I'm going to put 3 lengths on. 8x minus 1 is here. We have 4x plus 5 here. And we have 2x plus 11 here. Your assignment tonight, but just so you know, I put quotations around it, but I'm going to check it. I'll just kind of as one point, like bring it done tomorrow at lunch or before class. I want you to find me the value of x on this triangle. Cool, cool. I'm not a crook. That joke probably doesn't mean anything. Why are you looking?